Well, we started discussion on that cell model, right? That observation. I mean, when any nucleus contain that proton number or neutron number like 2, 8, 20, 28, 50, 82, or 126, they are observed to be highly stable. Highly stable means they will not further decay to other nuclei, or they will not pursue any fission or fusion reaction. Stable means they will not pursue any fission or fusion reaction, or they will not further decay. Okay. And also number of isotones are observed when that number of neutrons, number of isotones are maximum when that neutron number corresponding to 50 or 82. Number of isotopes also observed maximum when that number of proton corresponding to magic number. Also last point that I mentioned that most abundant element, that's not most abundant element, you can say the abundant element in the universe. These are actually oxygen. Most no, it's not true that most abundant. Okay, the abundant elements in the universe, abundant means easily available. Most abundant, if people are correct, most abundant means you have a hydrogen, helium, and so on. But that oxygen, calcium, and lead, they are also abundant in the universe, and that they have neutron and proton number, both are actually magic number. So these nuclei are actually double magic number nuclei. And abundant means they are actually stable, that's why they are abundant. Okay, please correct that statement. Then you have a last observation, that is your last observation is your radioactive series. Okay, if you remember, you have a 4 radioactive series. I'll write their mass number. Okay, then mass number, then you have a series name. Okay, your series, then parent nuclei, and you have a last daughter nuclei, or you can say that is stable daughter nuclei. Okay, so a mass like 4n plus 1, 4n plus 2, and 4n plus 3. There are basically 4 radioactive series having mass number 4n, 4n plus 1, 4n plus 2, and 4n plus 3. Or the significance of this symbol, I'll come. This series is called what? 4n corresponding to series, that is your thorium series. That is your thorium series. Then 4n plus 1 corresponding to neptunium series. Then 4n plus 2 corresponding to uranium series, and 4n plus 3 corresponding to actinium series. Okay, thorium series. Okay, parent nuclei is actually thorium having atomic number 90, mass number 232. Now, the name given according to the parent nucleus. Parent nucleus thorium, that's why it is called thorium series. Neptunium, parent nuclei is NP, neptunium 93, 237. Okay, that's why it is called neptunium series. Parent nuclei is neptunium. Then uranium, parent nuclei uranium 92, 238. Okay, actinium AC, atomic number 89 and mass number 227. Stable daughter nuclei. For 4n plus on, there will be a little bit bend here. Okay. The stable daughter nuclei or last daughter nuclei, PB. Atomic number 82, mass number 208. Then you have a Neptunium series, that daughter nuclei, that is your bismuth. Okay, bismuth. Atomic number is how much for bismuth? 83 and mass number 209.
सर वो लास्ट सीरीज दिखाई नहीं दे रही.
दे रही है. स्टेबल डॉटर न्यूक्लियाई फर्स्ट वाला क्या है? 82 लेट 82 and will be lead PB, atomic number 82, mass number 208. Then you have a next series, Neptunium, parent nucleus, sorry, last daughter nuclei is bismuth. Okay, atomic number 83, mass number 209. For uranium series, last stable nuclei corresponding to lead, atomic number 82, mass number 206. And for last series, again lead, atomic number 82, mass number 207. Okay, so there is a 4 radioactive series, you know? So this particle will undergo radioactivity. They will emit few alpha particle and few beta particle to achieve stability, है ना? इसमें कई सारे alpha particle, beta particle emit होते ना? This will be converted to another radioactive nuclei by emitting alpha or beta particle. Then that will also not be stable. They will further emit some radioactive particle, and at the end, this will be the product, and it will not further decay. Why it will not further decay? Because it's stable, because it has, if I see that first number, it contains atomic number, that is magic number of neutron 208 minus 82, that is on 26. So first in thorium series, both in the product or in the last daughter nuclei contain both proton number and neutron number that belongs to magic number, or this is a double magic number nuclei. So that's why it is not further decaying. Okay, so this parent will undergo few alpha and beta particle. As a result, it will convert it to PB, and it will not further decay because it contains proton and neutron number, magic number. Okay, and why it is called 4n series? I can see that parent nuclei and daughter nuclei, both mass number are divisible by, both are actually integer multiple of 4. Both mass number, I can see they are integer multiple of 4. The next series, you can see this bismuth. It contains that neutron number, that is on 26. Again, it is magic number. That's why it is not decaying further. And I can see here that mass number of both parent and daughter. There is a on remainder. If you divide their mass number by 4, you will get on remaining. You can check here. If it is 236, then it will be divided by 4. You will have on remaining. That's why it is called 4n plus on. And you can further verify other also. But why I'm discussing this? Because this observation is really important or interesting, because this contains magic number. That's why they are not further decaying. So these 5 observation actually surely indicating, you can mention these 5 observation are surely indicating that, or you can modify this 5 observation indicating that the nucleus is having cell structure. This 5 observation is indicating that nucleus is having cell structure. Okay, because you know that when you have a cell structure, if it is completely closed, that cell, that will be most stable. It will not further decay. That's why there are abundant number of isotopes. Number of isotopes, they are maximum because they are not actually decaying to other. Okay. Now, if that nucleus is having cell structure, you can mention that also. If the nucleus is having cell structure, then it should describe. If the nucleus is having cell structure, then it should describe first. It should describe first nuclear spin and parity. It should describe nuclear spin and parity. Okay, so if you are assuming that nucleus is having cell structure, then you have experimental data of nuclear spin parity. So cell structure should explain that spin and parity. Okay, then it should explain nuclear magnetic moment. It should explain nuclear quadrupole moment, nuclear electrical quadrupole moment, Okay. So scientists start thinking, if it has cell structure, then that cell structure should explain these properties. So these are the actually goal of nuclear scientists, that we have to build a model that will describe cell structure, and that cell structure should describe these properties. They should describe these properties. So they are trying to develop a model, and they have aim that model should describe not only that magic, why there is a magic number, also that cell structure should describe these properties. So cell model, this model actually successful to describe that magic number. Also, it can describe that nuclear spin parity, at least ground state, nuclear magnetic moment, electrical quadrupole moment, as shown. Now, this is the actually goal of nuclear scientists when they are building that model. So this model actually based on two assumptions. So every model, if you see in that nuclear physics, they developed that model actually developed based on certain assumption. And same is true here also. That's two assumption here. There's two assumption here. So first assumption, each nucleon inside nucleus inside nucleus is moving in its orbit independent of other. So inside nucleus you have a small size nucleus. In this small size nucleus, each nucleon actually moving or rotating in its orbit. So each nucleon, jitna nucleon hai, they are actually moving and that motion actually independent of other. That motion actually independent of other. So you can see, think like this. Each nucleon inside nucleus, they're actually revolving in its orbit independent of other. And that's why it is called. So this is actually assumption. They are assuming like this. Okay. And that's why it is called single particle cell model, because the rotation actually independent of other. That's why it is called single particle cell model. Okay. And the second assumption, each orbit has well defined energy and angular momentum angular momentum. ओके, ठीक है ना? तो हर एक जो मोशन है ना, हर एक न्यूक्लियन का जो ऑर्बिटल मोशन है, दैट orbital motion means it is revolving in an orbit. Each orbit is having well defined energy, है ना? When you have a orbital motion, then that orbital motion corresponding to have energy as well as angular momentum. And that energy and angular momentum, the energy and angular momentum of a orbit is actually characterized by VR. That is really important. You know, in central force problem, you have learned, right? When you have a orbital motion of, for example, Earth around Sun, and that is that orbital motion is actually possible by what? Why there is a orbital motion? Because of central potential. So here also, when that your orbital motion is happening inside nucleus, so each orbital motion is having energy and angular momentum, and that energy and angular momentum actually characterized by VR. VR is called centralized potential, and that is important. Centralized potential. Here is called centralized potential. So each nucleon is having orbital motion independent on other, and that orbit has angular well-defined orbit has well-defined energy and angular momentum that is characterized by VR. And VR is called central potential or centralized potential. VR is called centralized potential. Now, what is the meaning of that? What is called centralized potential? So, you know, actually, let me tell you that to calculate the energy or angular momentum, right? Because your nucleon is a quantum particle, right? If I talk about nucleon is a quantum particle. To describe the energy or angular momentum of orbital motion of nucleon, you have to have the potential energy of this nucleon, right? And when there is an orbital motion of a nucleon, there should be some central potential, and under the action of this central potential, this orbital motion is possible. But what is centralized potential? That is the question. So that is actually interesting thing. Suppose you have a nucleus, and suppose there are basically 20 nucleons are there. I'm assuming there are basically 20 nucleons are there. And if you take a nucleon, suppose this nucleon is having orbital motion. So you have a 20 nucleon, I'm specifying one nucleon. And this nucleon is actually having orbital motion. So what is the role of other 19 nucleon? They are actually creating a centralized potential. Under the centralized potential, this nucleon is actually rotating. If you taking this nucleon, this is rotating. So what is the role of other 19? They will create a centralized potential, and this nucleon is actually rotating under the action of this centralized potential. So centralized potential doesn't mean that your nuclear potential is central potential. Nuclear potential will never be central potential. But the central potential means average effect of other nucleon. You are not focusing any particular nucleon interaction. When you are taking VR, means average potential of all other nucleon on this particular nucleon. Potential between two nucleon, that will be non-central. But if you are taking average potential, then that will be centralized potential. You have to keep in mind that nuclear potential is never centralized potential.
Sir, this centralized potential is due to that nuclear force between the nucleons.
Nuclear force, but average force. I mean, not actually it's a nuclear force. If you are taking nuclear force, it is not nuclear force. Why? Because in this scenario, nuclear force will not work, because nuclear force is short range force. So when you are taking, I mean, for all other effect, nuclear force is only non-zero for neighbor, right? For neighbor it is affecting, but for large distance it will not affect. So this is not actually nuclear force. So if you are talking about nuclear force is actually non-central force. Nuclear force is actually non-central force. So VR actually, we don't know the form of VR actually. It's an interesting thing. Please keep in mind.
Potential, there is some potential due to
Average potential effect. When you are taking that, let me finish. It is very interesting. Let me finish, then you will ask me.
Okay.
If you are taking nuclear interaction, then that will be what? That will be non-central potential. When you are taking that potential of all, average potential of all other nucleon for a particular nucleon, that is actually, you are taking average potential, that will be central potential. Why? Because of this nucleon is rotating, and that rotating is possible when you have a central potential. Now tell me, when you are taking two nucleon potential interaction, that will be non-central. When you are taking average potential effect, that will be your centralized potential. But unfortunately, we don't know the form of centralized potential. That is actually, we don't know. Is it clear? Is this clear to all? हाँ ना बोल दिया करो. It's very unfortunate. हाँ. ठीक है ना? So, but we don't know that form of centralized potential. What is the average role of other potential, that we don't know. Then how will build that model if you don't know something? It's interesting for your research purpose also. When you want to describe something unknown, then from where we'll start? We'll start from simplest potential, simplest central potential. And to solve that Schrodinger equation, what is the simplest form of potential? आपने पढ़ा होगा क्वांटम मैकेनिक्स, कब आपका एनर्जी आइगन वैल्यूज आपको बहुत आसानी से मिल जाता है? टेल मी.
Free particle.
Particle in a box, right? Particle in a box. Free particle, but free particle is you cannot say that I can take free particle here, because what? You have a potential here.
Potential.
So I cannot take free particle, but if you remember particle in a box, that is also simple. So I'll start from simplest potential. But please keep in mind, we don't know the form of centralized potential. So I'll assume we have a centralized potential. Sorry. So first, I'll take infinite square wave potential. So first, they have taken infinite square wave potential. And when they're taking that infinite square wave potential and solve that Schrodinger wave equation, it successfully described that nucleus is having cell structure. Nucleus is having cell structure, but it only describe that magic number, or successfully describe that magic number. It successfully described that magic number, that is 2, 8, and 20. Okay, so the success of infinite square wave potential, when they are taking infinite square wave potential, they successfully describe that nucleus is having cell structure, and they have predicted, when they are taking that infinite square wave potential, they predicted many magic number, but out of this only these 3 were correct. Okay, but at least they describe that nucleus is having, at least this potential describe that nucleus is having cell structure, and also successfully describe these 3 magic numbers. Now they have sorry, this is your second. Then they have taken a harmonic oscillator potential. Harmonic oscillator potential. Okay. Okay, you can mention also. Again, harmonic oscillator potential describe that nuclear energy, or nucleus is having cell structure. Also it introduce degeneracy in a cell. Okay, so this harmonic oscillator, when they are taking harmonic oscillator potential, so again that potential describe that nucleus is having cell structure. But additional point क्या है यहाँ पे, that harmonic potential actually introduce the degeneracy in a cell, or degeneracy within the level. But again it describes that magic number, these 3 magic number again can successfully described by harmonic potential. Okay, so actually in harmonic potential it introduced degeneracy in a cell. They predicted magic number. They predicted magic number smaller than infinite square wave potential. इस इनफाइनाइट स्क्वायर वेल काफी सारे सेल काफी सारे मैजिक नंबर को प्रेडिक्ट किया था, उनमें से 3 ही करेक्ट था. इसने डिजेनरेसी को इंट्रोड्यूस किया, तो इसने भी बहुत सारे मैजिक नंबर को प्रेडिक्ट किया, बट नंबर ऑफ प्रेडिक्टेड मैजिक नंबर स्मॉलर देन इनफाइनाइट स्क्वायर वेल. बट अगेन इसमें भी मैजिक नंबर इन तीनों ही करेक्ट था, है ना. बट इसमें नंबर ऑफ प्रेडिक्टेड बहुत सारा, सपोज मान लो इसमें इसने प्रेडिक्ट किया, सपोज मान लो मैं एग्जांपल देता हूँ, इसमें 30 प्रेडिक्ट किया है, 30 में से 3 ही करेक्ट था. इसने 20 प्रेडिक्ट किया है, 20 में से 3 करेक्ट है. ठीक है, इस तरह की है, बट आई एम नॉट गिविंग एग्जैक्ट नंबर, इट इज लाइक दैट ओनली. ओके, so again we should improve that potential, right? So I cannot take that centralized potential is like infinite square potential. I cannot take harmonic potential. Then they have taken Wood-Saxon potential. Wood-Saxon potential. Okay. in this Wood section potential, again, it can successfully successfully predict this 3 magic number. But इसमें जो number of prediction था, that was smaller than harmonic potential. Suppose मान लो इसमें n equals to 20 था और उनमें से 3 correct था, then it is like n equals to 15 में से 3 correct है, like that. Okay. But it was simpler, है ना? ये भी fail हो गया, then they have taken this. Again it is failed, then they have taken this potential. Okay. Again it is failed. Then what they have taken? They have taken lastly they have taken Wood section potential. Wood section potential plus spin orbit coupling. Spin orbit coupling. SOC means what? Spin orbit coupling. So I'll discuss one by one. Okay.
सर साइड से दिख नहीं रहा क्या लिख
कौन सा
रहे
नहीं
हैं?
दिख रहा है? ये वाला spin orbit coupling है. So they have taken Wood section potential and there's some additional potential, that is spin orbit coupling. ठीक है. So you have to keep in mind for research purpose also. Yeah, when you will perform some research. Okay, you will do research means there is actually unexplored thing or unknown thing. If you are doing especially computational research, then to build a model you have to think something simpler. That simple, I mean that model should be simple. यहाँ पे जैसे मॉडल बना रहा है और मॉडल बनाने के लिए क्या चाहिए? उसको पोटेंशियल चाहिए, है ना? तो मॉडल में सिंपलेस्ट पोटेंशियल क्यों ले रहा है? इफ यू आर टेकिंग सिंपल potential means your model will be simple. When your model is simple, then it is very easy to handle. It is very easy to handle. Okay, but ऐसा नहीं है कि मॉडल आपने बना दिया और वो मॉडल आपका सक्सेसफुली कुछ डिस्क्राइब भी नहीं कर पा रहा है. Model should be simple, but it should describe that all the properties that you are planning to describe. Okay, so I'll take first infinite square wave potential. Infinite square wave potential. So they have taken like that, V of R. Okay, V of R equals to 0 when R is smaller than radius of nucleus. And it is infinity when R is greater than capital R. Okay, so I can describe like that. There was 0 to R. Okay, and this is the infinite potential. This side you have a VR. So from 0 to R, potential is 0, but at R means radius of nucleus, their potential is infinity. For the meaning of that is the meaning of this, that when a particular nucleon is revolving or rotating, other nucleon is creating centralized potential, but that centralized potential is formed like this. So other nucleon is creating some infinite square wave type of potential. They are assuming like this. Okay, so in a particular nucleon is revolving, what is the role of other nucleon is creating some centralized potential, and that form of centralized potential is infinite square wave potential. Okay, now how will solve that problem? So you have a to calculate that energy eigenvalues, you have to use, हाँ जी
सर ये जो लास्ट स्टेटमेंट आपने बताया और एक बार सर बताएंगे?
हाँ मैं बता रहा हूँ. So they are assuming that centralized potential, right? So when a nucleon is rotating or revolving, so what is the role of other nucleon? So other nucleon is creating some centralized potential, and that centralized potential is like a infinite centralized potential. Centralized potential means what? It will depends upon distance, right? Central potential means what? It depends upon position vector, not depends upon theta and phi. Okay. Now you know when you have a potential like this in quantum mechanics, it is very easy to solve. So to solve or to get that energy eigenvalue, you have to use Schrodinger time independent Schrodinger wave equation. But fortunately here your potential depends upon only position coordinate r. It is independent to theta and phi, right? Then you can use what? Anyone can tell me when your potential is actually time theta and phi dependent, or I can say that is spherically symmetric. Then how will solve that when your potential is spherically symmetric? And I'm asking what is the way to solve when your potential is spherically symmetric? You can use that
radial component.
You can use the method of separation of variable.
Yes.
That you have done in hydrogen atom, right? When your potential is like minus z square by 4 pi epsilon naught r, then you have used that method of separation of variable to calculate that energy eigenvalues. Okay. So I'll use that. Concept of separation of variables. So if I perform, I'm not going to do all that step. If you do this, you will get this kind of thing. Minus h cross square by twice m. Minus h cross square by twice m. Minus h cross square by twice m. Okay. M the mass of the nucleon. Then del square by dr square plus v of r plus you will have some additional term. Can anyone tell me what will be the additional term? So this is the VR. You'll have some additional term here. In the r coordinate, I'm taking only r component, because if you remember that r component in hydrogen atom gives you that energy eigenvalues like that. So I'm separating that theta, phi, and r coordinate. I'm writing r components. So I'm writing here that r components. So if you are writing, this is like a kinetic part. We'll have potential energy VR, that is, you know, infinite square wave potential, that is 0 and infinity at a given position, right? When r less than capital R and r greater than capital R. Now I'm asking, you'll have some additional term here. Can anyone tell me what is the additional term? This type of question you will get in the interview, not in competitive exam. क्या मिलती है? You are assuming centralized potential. If you remember, in a central potential you have learned this. V effective क्या होती है? V of r, then some L square term, right?
J square by 2m r square.
Exactly. So I'll write in quantum mechanics you are doing. So obviously I'll write L into L plus on h cross square divided by twice m r square. Right? And then you will have r component of the wave function, and that will be equals to E T of r. Okay. So when or I can write at r less than r. So your V of r, that will be 0, right? V of r will be 0, then so this Schrodinger equation will become minus h cross square by twice mass of nucleon del square by del r square, and then you will have L into L plus on h cross square divided by twice m r square. This will be equals to u r, that should be equals to u of r. Okay, so at this scenario V, this potential is 0, this will be reduced to this. Okay, na? So what is the solution of this equation? What is the solution of this equation? अच्छा, मैंने एक चीज पूछना भूल गया, मैंने पोटेंशियल V ऑफ R डिफाइन किया इन्फिनिटी का, कहाँ पे?
0 and R.
इन्फिनिटी कहाँ से? ग्रेटर देन
greater than R.
greater
capital
than
R.
equal to लिखो, greater than equal to, greater than equal to, greater than equal to. Now solution of this equation, what is the solution of this equation? The solution of this, exactly, this is a Bessel function. The solution of this equation is actually Bessel function. So I'll write the solution of this equation. That will be E of R, that will be R J L K R, where K is what? K is your wave vector, that will be root over twice ME by H cross square. Okay. And here this J is called Bessel function. J is called Bessel's function. This is the radial part of wave function. Now, of course, if I put that limit, so nucleon cannot exist at R equals to R. So I can say at R equals to capital R, your wave function should be, this R component of wave function should be vanishes, right? The concept of quantum mechanics, at infinite potential particle cannot exist. So at R equals to R, if you apply this boundary condition here, then what will happen? Your U of R, that will be, U of R will be what? So at R equals to R, your potential is infinity. What is the meaning of that?
Wave function 0.
It should be R component should be 0. So R component you have like this. So if you substitute, it means U of R means 0 means what? R J L K R. That should be equal to 0. So R cannot be 0. So of course this should be 0. R is the radius of nucleus. That is not non-zero. So obviously J L K R should be 0. J L K R is 0. And L is here orbital angular momentum. Sorry, here you have to write JL K capital R. K capital R. Okay. So for all possible values of L, that JL K R equals to 0. Where R is the radius of nucleus. Now, when we'll substitute, L is what here? L क्या है यहाँ पे?
Angular momentum quantum.
Exactly. L is your angular momentum quantum number. L is your orbital angular momentum quantum number. Now, if you substitute, the L values can be what? L क्या क्या हो सकता है? 0, 1, 2, 3, and so on, right? The possible values of L. Now, L is orbital angular momentum quantum number, and that can take value 0, 1, 2, 3, and so on. If L equals to 0, this is called S orbit, right? Called S orbit. So at L equals to 0, that J0 K of R, that is 0. J0 K of R, that is 0. Okay. And J0 KR, the value of J0 KR is how much? That is nothing but sine of KR by KR, that is 0. It means sine of KR, that is equals to 0. It means KR equals to how much? N of phi. Now, what is the possible value of N here? What is the possible value of N?
Sir, 1, 2, 3.
Why not 0?
L equal to sir.
If you take, see, if you take N equals to 0, KR equals to 0. R is non-zero, it means K is 0. R is non-zero, K is 0. K0 means what? K is what actually? K क्या है यहाँ पे?
Wave vector.
Propagation vector. So when wave vector or propagation vector 0, it means what? Your
Energy is
particle
0.
energy 0, or you can say particle is actually not rotating, first of all, or there is no orbital motion. Second thing, if you put, when you have K equals to 0, you will get JL 0. JL आपको क्या मिलेगा? जब K 0 है, यहाँ पे क्या मिल जाएगा आपको? JL 0 मिलेगा. JL 0, then your wave function U of R will be how much? R JL 0. Your wave function will be what? आपका wave function क्या था? U of R equals to like R JL, क्या आ जाएगा? 0 आ जाएगा. ठीक है ना?
Yes.
And JL 0 का value when L not equals to 0 क्या होती है?
Zero होता है.
0 होता है. So when L not equals to 0, then JL 0, it means you do not have any wave function. है ना? देखो यहाँ पे L non-zero है, then your JL, that term equals to 0. JL 0 means your wave function is 0. When wave function is 0, it means wave function 0, that is meaningless. Same concept you have learned in quantum mechanics also. So you have a wave function in a infinite square well, like root over 2L, 2 by L, sine n pi x by L. You cannot take n value 0, because if you take n value 0, then your wave function that will be 0. And wave function 0 is actually meaningless in quantum mechanics. You cannot take n equals to 0. But ab harmonic oscillator mein you can take n 0, because in harmonic oscillator, if you take n 0, you will get non-zero wave function. There is some significance there. But at n equals to 0 in infinite square well, that will give you 0 wave function. That's why you cannot take n equals to 0. क्या क्लियर है?
Yes sir.
Any doubt? क्या ये क्लियर है सबको?
मतलब L not equal to 0 कभी नहीं होगा.
हाँ, मैं कह रहा हूं कि आपके यहाँ पे a you cannot take, मैं कहना चाह रहा हूँ कि you cannot take n equals to 0. If you take n equals to 0, then what will happen? K should be 0. If K should be 0, this will be the form of wave function. Okay, and that wave function should be meaningful for all values of L. This wave function should be non-zero for all possible values of L. All possible
Yes.
values of L. But यहाँ पे जैसे आप L non-zero substitute कर दोगे, ये वाला टर्म क्या हो जाएगा? 0 हो जाएगा. If this term 0, then your wave function will be 0. If wave function is 0, then that will be meaningless. You cannot take n equals to 0. That I am trying to say. If you take n equals to 0, K will be 0, K will be 0, then this will be the form of wave function, and this term will be 0 for L non-zero. It means your wave function will be 0. That is meaningless. You cannot take n equals to 1. Sorry, n equals to 0. A similar concept like in quantum mechanics you have learned particle in a box. You cannot take n equals to 0 there also. It's same concept.
सर
हाँ
मेरा और एक डाउट
हाँ जी, हाँ
सर,
जी,
ये जो जेल है, ये
हाँ
इक्वेशन देखकर हम बोल सकते हैं कि ये बेसल फंक्शन होगा, बट
हाँ।
आर इंटू जेल क्यों हुआ सर?
आर इंटू,
आर इंटू जेल क्यों हुआ, मतलब
अच्छा
आर पार्ट क्यों लिया है?
अच्छा, आपने ये कह रहा हो कि आपका जो वेव फंक्शन आर इंटू जे एल के आर, ये आर क्यों लिए हो, ये पूछ रहे हो आप, ये
ये
बोला?
सर,
ओके ओके।
ये
नहीं,
सर,
ये तो आपका जो आपका जो इक्वेशन था है ना, माइनस एच प्लस स्क्वायर बाई ट्वाइस एम डेल स्क्वायर, जो उसका सॉल्यूशन जो है दैट इज द सॉल्यूशन। इफ यू सी इन मैथमेटिकल कॉन्सेप्ट, है ना, मैथमेटिकल बुक में देखो कि अगर उस तरह की डिफरेंशियल इक्वेशन है ना, तो उसका सॉल्यूशन क्या आता है, उसके साथ आर भी आता है। एक बार चेक कर लेना आप लोग, ठीक है? और बेटा
ओके सर,
इन द नेक्स्ट क्लास आई विल एक्सप्लेन आल्सो ना, because I thought you have learned this thing in mathematical physics, because there's a one chapter there, right? Special
ये
function,
सर,
है ना, वहाँ पे आप लोग एक बार देख लो, otherwise I'll take that concept and I'll discuss. But
ठीक है
I
सर,
have written here that solution of above differential equation. ठीक है? So it means kr equals to n pi. Now can I take or can I calculate the value of energy from here? So it means k equals to n pi by r, and k is nothing but, if you remember, that was like twice me by h cross square, right? That was equals to n pi by r. It means e will be here, कितना आ जाएगा, n square pi square h cross square by twice m into r square, ना, with n values, that is 1 2 3 and so on. Now if you substitute that n values, first least energy will be pi square h cross square by twice m r square. Then second possible values will be 4 pi square h cross square by twice m r square and so on. Now can you please tell me these values will be corresponding to which orbit? This value will be corresponding to which orbit? Can you tell me? This will be
ये सर,
corresponding to on S. This will be corresponding to 2s. Why this is on S and 2s? Because you have taken L equals to 0 and all possible orbit will be corresponding to S orbit. तो S, this is the least energy, है ना, उसके लिए फर्स्ट जो ऑर्बिट आएगा ऑन एस आएगा, नेक्स्ट एनर्जी दैट विल बी 2s एंड
सर
ऑल
नीचे
एनर्जी।
से बोर्ड विजिबल नहीं है।
ओके, मैं लिख देता हूं ऊपर, यू शुड टेल मी बिफोर ना। ओके, सो यू हैव ए एनर्जी लाइक pi square h cross square by twice m r square. Second, if you take n equals to 2, that will be 4 pi square h cross square by twice m r square and so on. आपने L equals to 0 सब्स्टिट्यूट करके ये सारे एनर्जी मिल रहा है, तो L equals to 0 का सारे जो ऑर्बिट होगी दैट विल बी योर s ऑर्बिट। तो पहला जो एनर्जी है दैट कॉरस्पॉन्डिंग टू ऑन s, दूसरा एनर्जी that will be 2s, तीसरा that will be 3s and so on. So whatever energy values you will get, that will all be corresponding to s orbit. But please keep in mind, यहाँ पे जो on 2 लिख रहे हो ये आपका principal quantum number है नहीं. There's no relation between n and l here. You have to keep in mind that also. Here I'm writing on 2 and so on. In atomic physics you learn this is like a principal quantum number, but this is not true here. It's like this is just an integer here. Okay, so in that cell structure, I can see that energy is discrete in nature. It means there's some discrete energy that corresponding to, I can see the cell structure here also, because these are L values are there's I mean there is only few L values are allowed. L values are discrete in nature, and that discrete L values will give you some cell structure. So first cell का जो energy है this much, 2s का this much and so on. Now if you put L equals to on, that will give you p orbit. that will give you p orbit. It means what I can say that again J on KR that will again be 0 because you have a JL KR that is 0 for all possible values of L. So that L equals to, when L equals to 1, this energy again be 0. And J on KR, इसका अगर expression लिखोगे, that is like sin KR by KR का square minus, दिख रहा है कि नहीं? दिख नहीं रहा है. Again I have to write J on KR that is equals to 0. It means J on KR का expression होता है sin KR by KR का square. And then you have cosine of KR by KR that is equals to 0. And this will give you, this equation will give you tan of KR equals to KR. This equation will give you tan KR equals to KR. And this is called transcendental equation. Tan KR equals to KR. This kind of equation you got. Where you have got this kind of equation? Somewhere you have learned this kind of equation.
Yes, sir.
Where?
Financial.
Exactly. So you can solve this, energy eigenvalues by using graphical method, or you can solve this equation to get energy eigenvalues by using computational method. Graphical method में पढ़े हो आप लोग, right? This kind of equation. This is called transcendental equation. You have solved this kind of equation in quantum mechanics. Okay, if you solve this equation, you will get that energy eigenvalue like this. I'm not going to solve this in details. You have learned this thing. Pi square h cross square by twice mr square into 1.43 chi square. Second energy, pi square h cross square by twice mr square into 2.46 chi square, and so on. To solve this equation, you will get first energy value, that is pi square h cross square by 2mr square with multiplication of this factor 1.43 chi square. Second, pi square h cross square by 2mr square with multiplication factor 2.46 chi square, and so on. Now can you tell me this energy will be corresponding to which orbit?
1p.
Exactly, this will be your 1p. This will be your 2p, and so on. Again, I'm saying this is not your principal quantum number. If it is principal quantum number, 1p is not possible. Here, this number is actually just an integer. Okay, so lowest energy corresponding to 1p, then 2p, and so on. So all this p here, because you have solved this for L equals to 1, and that all orbit L equals to 1 corresponding to p orbit. ठीक है? तो सबसे लोएस्ट एनर्जी किसका मिला है आपको? If you combine this, and this is true for all other also. When you solve, yeah, tell me.
Sir, if 1, 2 are not
Tell me.
principal quantum number, then you said that 1, 2 are integers. From where we get that 1 to 1p and 2p?
This.
Yes.
Means this actually this cannot be principal quantum number. Tell me why it is cannot be principal quantum number. On p principal, अगर on p orbit कभी देखे हो आप इलेक्ट्रॉनिक इसमें एटॉमिक स्पेक्ट्रम में L का वैल्यूज कहाँ से पॉसिबल है ना? L क्या क्या हो सकता है? 0, on, 2, up to n minus on.
Yes, sir.
ठीक है, अगर n इक्वल्स टू ऑन है, n इक्वल्स टू 1 है यहाँ पे, तो L का क्या वैल्यू पॉसिबल है बताओ?
0.
0 to 0. तो L का वैल्यू ऑन पॉसिबल है? नहीं है. ठीक है ना। तो यहाँ पे आप जो लिख रहे हो ऑन पी टू पी, ये आपका क्या है, जस्ट सिंबल लिख रहे हो। ऑफकोर्स दिस विल बी पी ऑर्बिट, बट इस पी ऑर्बिट को आप डिफरेंशिएट करने के लिए पहले वाला कम एनर्जी है, पहले वाला कम एनर्जी है तो उसको आप लिख रहे हो ऑन पी, दूसरे वाला थोड़ा ज्यादा है 2p, तीसरे वाला ज्यादा है 3p एंड सो ऑन।
Sir, it means that 1, 2, 3, it does not have any that significance, you know?
जस्ट
They are only symbol.
Exactly.
Okay.
ठीक है ना। ओके एंड सो ऑन, है ना। सो इफ यू सॉल्व, अब मैं पूछ रहा था कि सबसे एनर्जी कम किसका है, किसका एनर्जी सबसे कम मिला आपको?
1s.
1s.
And this I mean that JL KR equals to 0 for all other, है ना. So it will be, if you substitute L equals to 2, that will give you d orbit, that will give you d orbit. It means that J2 KR, again it will be 0, and again you can solve that energy equation, right? So they have solved that energy eigenvalues for all possible values of L by using boundary condition, and what they have obtained, that minimum energy is corresponding to honest orbit, and then किसका है? So they have obtained, they have obtained like this. If you see, first energy corresponding to on S, then on D, then 2D. Okay, sorry, not on D, sorry, 2D here, on D. On D, then 2S, 2S on F, and so on. 2S on F, 2P.
Sir, 2s नहीं आएगा 1p के बाद? 2s.
Well now?
Hello.
Yes.
Sir, 1p के बाद 2s.
नहीं, on P के बाद 2S नहीं.
Okay, 1d.
On S, on P, then आपने D के लिए सॉल्व नहीं किया ना, D के लिए करोगे, then next energy will be corresponding to on D. Next you'll have 2S on F, 2P and so on. अब बताओ यहाँ पे कितना न्यूक्लियन रह सकता है ना। हर एक ऑर्बिट में कितना न्यूक्लियन रह सकता है, that will be 2 into 2L plus on, है ना. That is the degeneracy of each orbit. यहाँ पे कितना रह सकता है, यहाँ पे L वैल्यू कितना है, 0 है. So this is on, 2 into on, that is 2. यहाँ पे कितना रह सकता है, आपने पढ़ा होगा ना इस तरह की. यहाँ पे S like this, यहाँ पे P like this, पढ़ा होगा ना. So from here you will get, you are getting this 2 into 2L plus 1. यहाँ पे 2 रख सकता है, यहाँ पे कितना रह सकता है, 6, यहाँ पे 10, यहाँ पे 2, यहाँ पे 14. These are called closed cell, है ना. ये आपका एक सेल स्ट्रक्चर है, इनके बीच में काफी सारे गैप है ना. This kind of similar thing you have learned in atomic physics also, है ना. So when you will have 2 nucleon, है ना. So this orbit, this is on closed cell, this on S is on closed cell, corresponding magic number will be how much, 2. When this cell are closed, कितना न्यूक्लियन क्लोज करेगा, यहाँ पे 2 न्यूक्लियन. If you have a 2 nucleon, then this cell will be closed, है ना. नेक्स्ट सेल क्लोज कब होगा,
जब इसमें 6 होगा.
6. So 2 plus 6, that will be 2 plus 6, that will be how much,
8.
next
18.
Next
20.
Next 34,
30.
next 40 and so on. So there in in infinite square OL, that central potential predicted that nucleus is having cell structure like this. They predicted many cell structure. I have not written all, it's not possible to write all that cell, but out of this I can see these are the magic number that is successfully described. You have many other magic number also. है ना। तो जब भी आपका समझ मान लो 2 न्यूक्लियन है कुछ न्यूक्लियस का, कोई न्यूक्लियस का, आप कहाँ से फिल करना शुरू करोगे न्यूक्लियस को, सॉरी न्यूक्लियंस को कहाँ से फिल करना शुरू करोगे, यहाँ से फिल करना शुरू करोगे, क्योंकि दिस इज द लोएस्ट एनर्जी। 2 न्यूक्लियन है, इसका मतलब आपका दैट न्यूक्लियस विल हैव क्लोज सेल स्ट्रक्चर। किसी न्यूक्लियस के पास 8 न्यूक्लियंस है, इसका मतलब क्या है, up to this cell that will be completely closed, है ना, and so on. So that closed cell structure is giving this many magic number, but इनमें से ये और ये that is actually matching with experimental data, and all
Sir,
are other actually false. हाँ
so oneness orbit have that 2 nucleon.
हाँ, ऑनेस्ट में 2 रह सकते हैं ना, इस तरह से। P है, P मतलब क्या है, this
Sir, but when we stated that their orbit of that nucleon will be independent of other nucleons. When we assumption when we
हाँ,
assumed
हाँ,
that
हाँ
first thing.
हाँ हाँ, तो यहाँ पे 2 रह सकता है, इसमें इंडिपेंडेंट डिपेंडेंट की बात क्या है, यहाँ पे आपका 2 तो रह सकता है, मतलब इंडिपेंडेंट। ऑफ कोर्स देयर इज ए मोशन, दे आर एक्चुअली इंडिपेंडेंट, नो डाउट। हर एक न्यूक्लियस का जो आपका ऑर्बिटल मोशन है, दे आर एक्चुअली इंडिपेंडेंट, एक दूसरे से कोई इनका रिलेशन नहीं है। बट एक ऑर्बिट में कितना रह सकता है आपका, 2 रह सकता है। अगर एस ऑर्बिट है, पी है तो कितना रह सकता है, 6 रह सकता है, अकॉर्डिंग टू पाउली एक्सक्लूजन प्रिंसिपल।
Okay.
So motion independent है, but they can stay in a orbit, they can stay together in a orbit, their
Okay.
motion are independent. Independent का मतलब क्या हुआ है, एक के साथ दूसरे का कोई रिलेशन नहीं है, like that.
Okay.
Well,
They
I'll
can
continue from here tomorrow, it will be more fine. Okay.
Thank you, sir.
Okay.
Thank you.